start out with a bunch of vocab. I'm going to start by talking about a coordinate plane first. Hopefully we know some things about a coordinate plane. We have an x-axis that goes left to right. Are you on the right place? Everybody's good? X-axis goes left to right. To the right, all the numbers are positive, and to the left, all the numbers are negative. Then there's a y-axis that goes up and down. As we go up, the numbers are positive. As we go down, the numbers are negative. Are you guys familiar with the quadrants of a coordinate plane? We start in the first quadrant over here. Don't ask me why it's over here. I'm not entirely sure. But that's the first quadrant. That's like where everything starts. Then the quadrants go counterclockwise. So quadrant 2 is over here. Quadrant 3 is over here. And quadrant 4, our last quadrant, right over there. Everybody cool with that? We're going to imagine these coordinate planes as a clock. They're going to start at the beginning of quadrant 1. And we're always going to be talking about degrees here for this class. I don't know if you guys in Algebra 2 did radians, but we're always going to do degrees here. So 0 degrees is where we start. And then we're going counterclockwise around 360 degrees. So each segment is 90 degrees. This is 90 degrees right here. Another 90 degrees brings me to 180 degrees. And then another 90 degrees brings me to 270 degrees. And then we go all the way back around to where we started. That is 360 degrees. Everybody cool with that? So, some more vocab that we're going to talk about. Standard position. We're thinking about like the hands on a clock. Standard position means that the vertex of our angles are always going to start in the center of our coordinate plane, like a clock, right? The hands start at the center. The first part of the angles that we are going to be creating in these coordinate planes starts at the initial side. My initial side is always going to be on 0 degrees. So where we have 0 degrees over here, I want you to draw the first side of your angle. Then I have something called the terminal side. The terminal side is the important side that we're really going to be focusing on. That terminal side is the other side of our angle. So we have one hand of our clock going this way always. The other hand of our clock will be somewhere around here. Okay? Let's put that terminal side for just an example over here. Let's say that angle measure is 120 degrees. Do we see how 120 degrees ends up somewhere between 90 and 180? Okay, it all makes sense in the little clock that we're looking at. So that's our terminal side. Those two sides, the terminal and the initial, form an angle in between them, right? That angle is 120 degrees. The angle that we care about is going to be called the reference angle, and it is not in between these two angles, or these two rays. It is going to be an angle formed by the x-axis and the terminal side. So here's my terminal side. Here's my x-axis. The angle in between them, we're going to call that reference angle theta. It's a Greek letter theta. It's just a little symbol. Doesn't have to be perfect. Everybody cool with that? Okay. So, it is very important that we remember that theta goes in between the terminal side and the x-axis. A little silly thing that Mrs. Smith taught me this year that I think maybe will help you remember this is that the angle always goes back to the x. Always go back to your x, which is great advice in math and bad advice in life. Right. Okay. Maybe that'll stick in your brains. Otherwise, how I remember this is we are going to be drawing kind of like bow tie shapes. So if you think about this angle, and I'm going to you don't have to copy this, but I'm going to draw like, imagine that this is a bow tie. Okay, we'll have like kind of a bow tie shape. Maybe you can see that, maybe you can't. I'll do another one in a second. But when finding your reference angle, again, remember your bow tie triangles. What I don't want to see, and I'm going to draw that same exact example out where I have this 120 degree angle here. I do not want to see your reference angle go in here. Again, that's going to the y-axis. And if I draw out a bow tie shape, or sorry, this is an hourglass. I don't want to see hourglasses. I want to see bow ties. That makes a little bit of sense. Just a little bit. Okay. All right, so what we are essentially going to be doing is we're going to take a coordinate plane, and first and foremost, we're going to be trying to figure out what those reference angles are. So I recommend you always start by drawing this little bow tie ghost shape. That doesn't necessarily mean we're going to be using that entire bow tie, but we are going to be using one quadrant of it at minimum. You're going to have an initial side, and then you have a bunch of different terminal sides that we could use. If this right here is my terminal side, my reference angle goes in between that and the x-axis, and we would get a triangle in here. Guess what? Those are right triangles. If my terminal side went over here, think about where your reference angle would go. It would have to go in between there and the x-axis, and we would get another right triangle over here. We could do the same thing in all four quadrants. So again, if I put my terminal side over here, my reference angle would go in between there and the x-axis, and I would get a nice little right triangle in there. If it went over here, here's where my reference angle would go. And then here's my right triangle. Okay, so it's kind of going to look like one of those options. It will never look like an hourglass shape. Don't do it. Good? All right. So let's do an example. I want the angle 150. The first thing I need to figure out is what quadrant is 150 going to go in. I'm going to start at my initial side. My initial side is always 0. Then I count, do a little bit of counting here. These sections each go by 90. So the first section is 90. This next section is 180. 150 is somewhere in between 90 and 180, yes? So I'm going to draw my terminal side, 150, approximately in there somewhere. What we are now trying to figure out is what is the reference angle? I know it's called theta, but what is the measurement of theta? To figure that out, I just determine what is the distance in between that terminal side and the x-axis. So the distance between 150 degrees and 180 degrees is 30 degrees. So this angle theta is a 30-degree angle. Questions on that? Okay, so let's try some more examples. We'll do one of these. I'm going to skip around. I'm not going to do all of these. The first thing we need to do is draw our coordinate planes. I like to do the little bow tie shapes sometimes to help me remember that I need a bow tie, not an hourglass. I'm going to draw my initial side, which is at 0. And then I start counting. So I know that my first section is 90. And I already recognize that 60 is going to be somewhere in between 90 and 0. So I know my terminal side is going to go here in quadrant 1. Then I'm thinking, okay, if this is 60 degrees right here, what is the distance between the x-axis, which is 0, and 60 degrees? This reference angle theta is a 60-degree angle. Does everybody see what happened there? Let's try number 2. I'm going to do the same thing, starting with a coordinate plane. Oh, coordinate plane. A little bow tie shape. Starting with my initial side at 0. Then I'm going to start counting around. First section 90, second section 180, third section 270. Now I'm somewhere in between 180 and 270. So there's where my terminal side goes. I'm going to draw my reference angle. Remember, always go back to the x. Good advice in math, bad advice in life. There's theta. And I'm trying to figure out what is the distance in degrees between 225 degrees and 180 degrees. 225 minus 180 tells me theta is going to be 45 degrees. questions there? Let's do one more. I'm gonna skip to number 6. Again, coordinate plane. Little bow tie shape. Best bow tie I can do. My initial side here is 0. I'm going to count around until I get to 300. So 90, 180, 270, all the way back to 360. And my terminal side is going to be somewhere in between 270 and 360. So I'm ending up in quadrant 4. This is 300. I'm figuring out what's that reference angle, what's that distance between 360 and 300. That would be a 60-degree angle. Any questions on that part? Okay. What have we noticed about these angles? Anybody? In the 4 examples that we've done so far, we've had 60, 45, 30, 60. Guess what? All of the angles that we are going to see are the angles in our special right triangle. So they are going to be 30-degree, 60-degree, or 45-degree angles for all of these. Let's do a little bit of a refresh on our 30, 60, 90 and our 45, 45, 90 triangles. The first 2 examples here are our 30, 60, 90s. Okay, as a little bit of a refresher, the first side in a 30, 60, 90 is X. It's across from the 30-degree angle. That's like my short side. The hypotenuse is going to be across from the 90-degree angle, and that is always 2 times X. And then the long leg is across from the 60-degree angle, and that is always radical 3 times X. Okay, so we remember those magic numbers. Okay, let's talk about 45, 45, 90s now. Oops. In a 45, 45, 90, the 2 legs are the same. They are both X. And the hypotenuse across from that 90-degree angle is radical 2 times X. So there are 3 magic numbers that we need to remember. For 45, 45, 90s, that magic number is radical 2. For 30, 60, 90s, we have to remember the hypotenuse is times 2, and the long leg is times radical 3. Everybody good with that? We remember? Good refresher? Okay. Now, we're going to talk about sine, cosine, and tangent, and we're going to do these without calculators. So it's going to be a little bit tricky here, but we're going to figure it out quickly, I think. So sine of 30. Remember, the angle that's next to the trig name tells us what angle we should start focusing on. So there's my 30-degree angle in this example. Sine of 30, if I'm talking about sine, I'm thinking SOHCAHTOA. Maybe I write this at the top of my page. SOHCAHTOA. Sine is opposite over hypotenuse. So when I'm finding the sine of 30 degrees, I'm going to look for the opposite side to that 30 degrees, the opposite side being X. And I'm going to look for the hypotenuse side of that triangle, which is 2X. I want us to think about what this reduces to. So imagine this is 1X over 2X. X's, if there's one on top and one on bottom, they're going to kind of cancel each other out. So this would reduce to 1/2. The sine of 30 degrees is 1/2. Let's do the same thing for number 2. Now I'm looking at sine 60. So I'm going to focus on this next triangle with my 60-degree angle. We know sine, again, is opposite over hypotenuse. The opposite side this time is a radical 3x, and the hypotenuse side this time is still that 2x. Again, thinking about what this reduces to, and those x's cancel each other out, this is going to reduce to a radical 3 over 2. Everybody good with that? The last one, let's look at this 45, 45, 90 triangle. 45 degrees, we're going to focus on this angle right here. Tangent is opposite over adjacent, TOA. So I want the opposite which is x, over the adjacent, which is also x. If I have 1x over 1x, that reduces to 1. Everybody cool with that? So take a look at what we just did. When we were reducing those fractions, those x's were canceling themselves out every single time. So we're going to skip that step altogether. We're going to skip the x part. Take a look at these triangles. Same 30, 60, 90, and 45, 45, 90 triangles from before, but instead of x's, we've replaced them with 1s. Everything that we do here on these coordinate planes is going to have a scalar of 1. We're imagining x is just 1, okay? So across from your 30-degree angle in a 30, 60, 90 is a 1. No matter where that 30-degree angle is, it'll be a 1. And then the hypotenuse, 2 times 1 is 2. The long leg, radical 3 times 1 is radical 3. Okay, everybody got that? And a 45, 45, 90 triangle across from any 45-degree angle, again, will be a 1 instead of an x. So far, so good. You still with me? Okay. We're going to put it all together. Everything that we've just done, all together. So let's take a look at this first angle. It wants us to find sine, cosine, and tangent for the angle 150. Now, normally, we would put this into our calculators, but we want to be able to do this without our calculators. That's where these reference angles are going to come in handy. Instead of finding the sine, cosine, and tangent of 150, we're going to use smaller reference angles to help us with our special right triangles. So we're going to start with a coordinate plane. I'm going to draw my bow tie, the best bow tie I can muster. I'm going to write my initial side on 0 degrees, where it always goes. And then what quadrant is 150 going to end up in? 1, 2, 3, or 4? It's going to end up in quadrant 2. Somewhere between 90 and 180 is where 150 goes. Remember where your reference angle goes. Always goes back to the x. Good advice in math, bad advice in life. Here's my reference angle, theta. What is that reference angle? The distance between 150 and 180, Caitlin? Okay, let's write 30 in there. I'm just going to erase it because I need some room. Okay, so now we're going to focus in. I'm going to focus in on this triangle right here. I'm going to draw it in. That's not a ghost triangle anymore. That's an actual triangle. We know that these are special right triangles. So if that's 30, guess what? This angle right here is 60. Then I'm going to use what I know about coordinate planes and about special right triangles to not only fill in what those side lengths are going to be, but also to fill in the proper signs, positive versus negative, of these sides. So let's start with where I always start is the 30-degree side. Okay, this 30-degree side is going up. Across from the 30-degree side is always a 1. And because it's in the positive region going upwards, we know that as we go upwards, our numbers should be positive, right? So that's going to be a positive 1 right there. Across from my 60-degree side is always where my radical 3 goes. So I'm going to put a radical 3 over here. And we can see this side starts at the origin and goes to the left, this way. As I'm going to the left, I'm going more negative on the x-axis. So that radical 3 should be a negative radical 3. The last side is my hypotenuse. The hypotenuse goes across from the right angle. This hypotenuse is 2, because that's my rules from my 30, 60, 90s, right? We see them up there. Now our hypotenuse, no matter where it falls, and I'm going to write a note up here at the top, hypotenuse is always positive. That's because we're thinking about right triangles, and when we're finding the hypotenuse of right triangles, we're thinking Pythagorean theorem. So when we find the hypotenuse in the Pythagorean theorem, we're always squaring those legs. So whatever those two legs are, whether they're positive or negative, they're getting squared, and that's going to make them positive anyways. So your hypotenuse is just never going to end up as a negative number. That's just something you have to accept. Okay, everybody got this filled in? Everybody sees where these numbers are coming from? Because that's all the work we have to do. Now we're going to write sine of 150, cosine of 150, and then tangent of 150. I'm not looking at 150-degree angle. I'm looking at my reference angle 30. Okay, so everything's going to focus on 30, but that's just kind of like helping me get to that bigger angle 150. Sine we know is opposite over hypotenuse. That's so in SOHCAHTOA. So opposite that 30-degree angle is a 1, and the hypotenuse of this triangle that we've created is a 2. Oops. Well, change color. There we go. So sine of 150 is 1/2. Everybody with me still? Let's do cosine. We know cosine is adjacent over hypotenuse, so I'm going to look at the adjacent side to 30. The adjacent side is negative radical 3, and the hypotenuse is 2. So cosine of 150 is negative radical 3 over 2. And then the last one is tangent. Tangent of 150, we look for opposite over adjacent. The opposite is 1. The adjacent is negative radical 3. Can I leave my numbers like that? No, I can't have a radical in the bottom, so I need to finish this off by rationalizing it. Remember, to do that, we're just going to multiply by that radical on the top and the bottom, which leaves me with radical 3 over negative 3, or just negative radical 3 over 3. Okay, that felt like a lot. Everybody good? You're not going to be able to use your calculator on this. So we don't need our calculators. We're just going to do it in our heads. We're going to be okay, I promise. Let's do another one. Number 2, 315. I'm going to draw out my coordinate plane. And I know 315, if I think about going in a circle, is going to go in quadrant 1, 2, 3, or 4. 4, it's going to go over here. Somewhere between 270 and 360 is 315. If it helps you, draw out those bow ties every time so we know where our reference angle is going to go. Our reference angle ends up right here. Let's fill in that triangle. Okay, what's the measurement of that angle right there? What's my reference angle? 45. The distance between 360 and 315 is 45 degrees. Okay, so that means here's my right angle, and here's my other 45-degree angle, and we're going to fill them in. Look at my reference up here. Across from the 45s is always a 1, and the hypotenuse is radical 2. The hypotenuse is easy. That's always going to be positive. Then I got to think about the signs of these 1s that I put in here. So the first 1 here, this green one, it's going downwards. So I want a negative 1. This one over here is going to the right from the x-axis, or from the origin. So that's going to be a positive 1. Everybody see where those numbers came from? Let's do sine, cosine, and tangent. Sine of 315, opposite over hypotenuse. We're referencing this angle right here, our reference angle. Opposite is negative 1. Hypotenuse is radical 2. We cannot leave it like that, so I'm going to rationalize. This ends up as negative radical 2 over 2. I'm going to do the same thing for cosine. Hey, guess what? When I do cosine, I also end up with 1 over radical 2, and I know I'm going to need to rationalize that, so let's just copy this. The only difference is it was 1 over radical 2 instead of negative 1 over radical 2, so this is just going to end up as a positive radical 2 over 2. Then my last one is tangent. I want opposite over adjacent. The opposite here is negative 1. The adjacent is positive 1. This ends up as negative 1. Any questions on this? Can I do one more that's a little bit weird? Okay. This is what the majority of your homework is. I actually don't think there's any of the weird ones on this homework that you're going to see, but I'm going to show you a weird one anyways. So let's take a look at number 4, just so we are exposed to it for one time. I'm going to draw my coordinate plane. Ooh. I don't like that coordinate plane. Okay. Where is my terminal side going to be if my angle is 90? Is it going to end up in a quadrant? What's going to happen to it? Yeah, it's going to end up on the y-axis. We know that this is 90 degrees right here. So my terminal side ends up going straight up and down on this y-axis. And we're like, uh-oh, what does that mean? Okay, hear me out here. Even though this is not forming a triangle, because we have this straight up and down line, I want us to draw out our little ghost bow ties anyways. So here's my little bow tie. Just bear with me. This arm of my angle, this ray, is pointing upwards. So I'm only going to focus on the 2 upper parts of my graph. I don't care about these guys down here. So let's focus up here. How far up is this ray pointing if everything that I'm doing is a base of 1? Well, it should be going up 1. So this side length, where it's showing how far up it's going, should be 1. Does that make sense? How far up you're going is 1. How far to the left or to the right is this line pointing? Does it point to the left or to the right at all? Not really. No, it's going straight up. So for the left side, I would say it's going 0 units to the left. And for the right side, I would say it's going 0 units to the right. I'm going to fill in these triangles a little bit so we can see them. So this is like an imaginary triangle with side lengths of 0 and 1. Still a right triangle. Let's figure out what would the hypotenuse of this hypothetical right triangle be if the legs are 0 and 1. Well, 0 squared is 0. 1 squared is 1. My hypotenuse squared is 1. The square root of 1 is 1. So this hypotenuse, even though it's got imaginary legs, still has a hypotenuse of 1 or 1. Everybody cool with that? So again, even though these are fake triangles, I still have technically a reference angle. It could be here or it could be here. Doesn't really matter which one you decide to use. But let's find sine, cosine, and tangent for these imaginary little triangles. So for sine of 90, I start with my reference angle. I want opposite over hypotenuse. So 1 over 1 is 1. Oh my gosh, this pen. 1 over 1 is 1. For cosine 90, adjacent over hypotenuse. The adjacent here is 0. So 0 over 1 is 0. And then lastly for tangent, tangent is opposite over adjacent, 1 over 0. We know we can't divide by 0, so this is undefined. Any questions on that? Again, kind of a weird one. You won't see that on your homework just yet. We will keep working through examples like that because they're a little weird. All right, your homework is in your packets.